Hi everybody. So today we're going to be taking notes on the law of sines when we're given side angles. So this is objective 11.1b. The topic is the law of sines when we're given side angle, and our objective is to determine how many solutions are possible and the other one would be to solve, so that would be objective 1, 2, to solve triangles when given sine, or given side angle. And we'll be using the law of sines, of course, just like we did yesterday when we were given angle, side angle, or angle, side. The only issue is with side angle, it creates all of these different scenarios, and some scenarios will create no solution, and some will create one solution, and some will create two solutions. So what I'll do is show you how to determine that. We'll talk about the 8 different cases that are possible here. So let's just say here, when two sides of a triangle and angle opposite one of them are known, the law of sines can be used. So we'll say that when two sides and an angle opposite one of them is known, and that gives us side angle. You can use the law of sines. To determine how many possibilities there are. Actually, let me just make sure I'm saying that. You can use the law of sines to solve the triangle. However, you also are going to use just the sign of a right triangle to help you to determine this as well. So, excuse me. I apologize. Okay, so what are the possibilities for when we're given side angle? Two sides in a row, and then an angle. There's 8 different situations. So case 1 is going to be a no solution case. Okay, and in case 1 through 5, so I'm just going to write that here. In cases 1 through 5, the angle that we're going to be given is acute. Okay, so case 1, there's going to be no solution, and here we have, let's draw a picture here. So we're going to draw a side here, and then we're going to draw a side here, and here's our angle. This is our angle. We'll call it angle B. Okay, so there's angle B. We're going to call this side C, and so that means up here we're going to put angle A, and here's side B. And just notice here that this is side angle. Let me highlight that. Side angle. Okay, so notice that side B is just really too short to meet side A over here, and so no angle is created. And so in this case, side B is less than the height of this triangle. This would be the height right here. And I'm going to just get my eraser here, so I'll partially erase so we can see that that's not part of your triangle. It's just the height of the triangle. So the base, our side B is less than the height, and the height, of course, is less than C. So in that case, when the base is less than the height, there is no solution. Okay, here's case 2. In case 2, we're going to get one solution. Okay, in this case, B is going to be less than C again. We'll draw that same picture. So here's side A. Here's angle B. Here, and this is side C. And what's going to happen here is side B is going to be exactly this is angle A up here, and here's angle C. So you see that the base right here, or not the base, side B is exactly the same length as the height, and it's perpendicular to side A here. So B is less than C in this case, but we could also, let me rewrite that, or we could say B is equal to the height and they're both less than C, and that'll create a right triangle. Case 3. In this case, we're going to get 2 solutions. Okay, so let's see here. I don't want to write everything differently every time I turn around. All right, so in this case, B is going to be less than C again, but it's going to be greater than the height. So the height is going to be less than side B is going to be less than side C. So we're going to draw side A. Here's angle B. Okay, here's the height. So here is angle B, side C. This is side A. And then side B is here. But if you rotate it around in an arc, it'll also hit the other side here. So this could be side A here and angle C, or angle C here and side A could be this whole thing. So you could get 2 possible solutions in that case. So when the height is shorter than the opposite of angle B, and they're both less than side C, you get 2 solutions. Okay, here's case 4. Again, remember, these are all cases where the given angle is acute. This one's going to be 1 solution. Okay, and in this case, B is going to be equal to C. And so that means that we're going to, if you can imagine for a second, here's angle B, which is our angle that we're given. And then here's side C, and then here's side B here. And this would be actually a isosceles triangle. So if the 2 given sides are the same measure, then you have an isosceles triangle and you'll get one solution. And then the last one here for acute angles, if we're given acute angles, here would be case 5, and it is also 1 solution. And in this case, side C, this is the first time this is going to happen, is going to be shorter than side B. So here we have side A, which we don't know anything about its measure. Here's angle B. And here's side C, and then side B would be actually longer. And when you rotate it around, it'll only create that 1 triangle there. And that would be angle A. So if B is the opposite of the angle that you're given, because remember again, let me just remind you, we're doing side, side, angle. So we have this pair of opposites here. So if the side opposite the angle is longer than the side that's adjacent to the angle, then you're going to get 1 triangle, possibly. All right. Those are the cases where you're doing acute. In cases 6 through 8, the angle I give you will be obtuse. Okay, so here's case 6. In case 6, we're going to get no solution. And so it looks a lot like case 1. But this time when we draw the picture, what we're going to do is we're going to draw an obtuse angle for angle B. So there's our given angle. Here's side A. And here's side C. And this is going to be angle A up here. And then side B is here. And this is the length of side B. And as you see, if I rotate it around, it'll just never reach that opposite side. And so there's no solution here. And again, this is because B is shorter than the actual height of this triangle, which is created out here, which is less than, of course, side C. So no solution if side B is too short. Here's case 7. This one is no solution as well. And this one, side B will be the same length as side C, but again, this is an obtuse angle. So if we have, here's side A, here's angle B, it's obtuse, and here's side C, and up here's angle A, and then side A, or side B would be the same length as side C. And as you notice, as I rotate it around, what's going to happen is it's just going to tap the bottom of, if I rotate it around, it's just going to meet side C, and they're just going to create an angle. It won't create a triangle. So if B is equal to C and the given angle is obtuse, you get no solution. Last case, case 8. And this is also a no solution. So if B is greater than C, I believe that this is actually a solution. Let me just think on this for a second. I'm looking at my picture here. This is one solution. Okay, so this is one solution. All right, and so here side B, which is our side opposite, is going to be greater than C. So if we have our side that we don't know anything about, A, here's angle B, it's obtuse. Here's side C, and then here's side B. And side B is definitely longer than side C. You can see that, whoops, you definitely get one triangle created there. And so there you could get one solution. So notice in both situations when, I guess I wrote it over here, where B is greater than C. So when your side opposite, your given angle is greater than your side that's adjacent, you're going to get one solution. All right, and so I made a couple videos and I put them up on Canvas. So if you wanted to actually learn how to draw these pictures to indicate or determine whether you have 0, 1, or 2 solutions, you can watch those videos. Today what I'm going to do is just show you how to do this mathematically. So these are the 8 cases illustrated that lead us to 3 possibilities in the side-side angle situation. Okay, in example 3, we have triangle QRS, where angle Q is 43, side R is 28, and side Q is 15. All right, and so we have a pair of opposites. We have side Q and angle Q, and we have R. So what I'm going to do is just draw a picture, and when I draw a picture, I always like to put the angle that I'm given when I'm doing side-side angle on the left-hand side, and then I just draw the base of that angle. And then 43 degrees, I'm just going to make something that says 43, because I'm just drawing a depiction here. Okay, and so since this is side-side angle, this will be side R, and then over here, this is going to be side Q, which is 15, and this is R equals 28. And so we want to know, so I guess this would be side S up here and S down here, and angle R would be somewhere over here. Okay, so I want to see if this is an actual triangle or not. So if I wanted to use the law of sines to do that, well, I have a pair of opposites here. And so what I want to know is, what is angle R? So I have half of angle R here. So what I would do is I would just say, okay, so angle R, so I'm going to say the sine of R over R equals the sine of Q over Q. Do some substitution there. So we'll do the sine of R is over R, which is 28, is equal to the sine of Q, so the sine of 43 over side Q, which is 15, and we will see what happens here. So we're going to solve for sine of R, so we're going to multiply both sides times 28, so we get sine of R is equal to, I'm going to rewrite that, 28 sine 43 over 15, and that gives me sine R is equal to, when I put that in my calculator, it gives me the value 1.2873, and if I were to plug that into my calculator, note if maybe I wasn't paying attention and I forgot that the sine of R has to be within the range -1 to 1. So this is outside the range. So maybe I would forget to do that. So I would multiply both sides times, or not multiply, but take the inverse function of both sides. And when I do that, it would say R is not in the domain, or it'll say domain error. And when that happens, because this doesn't work on the unit circle, here you have between 0 and 180, okay, where sine is positive. This is 1 and this is -1, and this is 1 up here. We're just not going to get a value. And so in this case, that means that no triangle is possible. No triangle is possible. Okay, so that's how you would use the law of sines for that. So we can't solve this triangle. All right, we're going on to example 4. Okay, so it says in triangle XYZ, we have angle X, which is 39.7 degrees, side X, so we have that pair of opposites there, is 23.5 units, and side Y is 9.8. Solve the triangle. So we know those 3 of the 6 measures, and we make a drawing. Again, I like to put the angle here on the left. That's just my preference. And so side X will be over here, and it's really long, 23.5 in size, so that's side X. And this is, remember, side angle, so I'm going to go ahead and go this way, side angle. Okay, so here we have 39.7, and so this would be side Y at 9.8. And so when you kind of look at that, just that sketch right there, it makes sense that if I were to rotate this angle around here, this side X rotated around on this axis right here, that it would only make one triangle. But let's see how we know that it's only going to make one triangle. Again, we have this pair of opposites, and what we're doing now is we're looking for angle Y right here. And so we could say that the sine of Y over Y equals the sine of X over X. We'll plug in sine of Y, so we don't know angle Y, but side Y is 9.8 equals the sine of X, which is 39.7 over X, which is 23.5. Multiply both sides times 9.8. So we get sine of Y equals 9.8 sine of 39.7 degrees over 23.5. And then, of course, if I were to simplify that, that would say sine of Y equals, let me get this value exactly, I have it written down right here, approximately 0.2664. And so if I were to go on my unit circle here, where your sine of Y, remember, is your your Y coordinate, and I put that point right here, 0.2664. So on my unit circle, I'd be talking about this angle here and over here as well, because remember, sine is positive in quadrant 1 and 2. So I'd have to kind of go into my calculator now and find the sine inverse. So Y is equal to the sine inverse of 0.2664. So I'm going to do that. I'll just go ahead and go into Desmos and do that. And let me just wait for that to open. And I'm going to put my, make sure I'm in degrees here. And then I'm just going to do sine inverse of 0.2664, and you see here that we get a value of 15.45, so 15.5 degrees. Now remember that sine inverse is defined in quadrants 1 and 4, so this is 15.4 degrees. Well, we'll just say 5. And then, no, I think it was 4. Okay, so we're going to say 15.4 degrees here. And so that would definitely work in our picture, but this is also 15.4 degrees here. So if I subtract that from 180, well, 180 minus 15.4 is a really big angle. Let's see what it is. It's 164.6 degrees. Well, I don't think that's possible, because if you look at our triangle up here, we have 39.7 degrees already used up. So there's no way that this could be 164.6 degrees, because if I were to add 39.7 to 100, I would be beyond 180 degrees. So I couldn't create an angle with a triangle with that. And so in this case, this solution is no good. And so there's one solution. All right. And so now what we need to do is we need to, so we know that angle Y, which we just solved for, was 15.4 degrees. So that's 15.4 degrees. And now we can find angle Z by just using your angle sum theorem. So if we do angle Z, I'm just coming over here to do a little work here. That would be 180 minus 39.7 minus 15.4, which is, let me just look here, 129. Sorry, that is not correct. 124.9 degrees. And so 124.9 degrees would be that solution. Now the only thing that we have left to do is solve for side Z. And again, I would go back and use this information here. Now this time we're looking for a side. So if you recall, I'm just going to scoot over a little bit here. I'm going to do this last side here. We're going to do side Z over sine of Z, which is 124.9, is equal to side X, 23.5, over sine of X, so sine of 39.7 degrees. Then we'll multiply both sides times the sine of 124.9 times the sine of 124.9. And we'll plug that into the calculator. And Z, I know you trust my work right here. So Z is approximately 30.2 units long when I plug that in. And so we have solved that triangle. So the point of this lesson here, for example 4, was to use the law of sines to try to determine how many triangles were created, because in this example we were given side angle. Again, after we drew the depiction, it was easy to determine that. And so there's an example how to get one solution. All right, last one here, and then we're done. In triangle ABC, we have angle B is 29 degrees, side B is 15, and side C is 20. So again, we have a side angle situation. I like to draw the picture. So see, here's angle B, and side C is about 20 units long. I'm going to put side C here, so angle A is over here, and side B is 15 units long. So I'm going to put that here, and then I'm just going to show you as I rotate that around over here, it's going to tap here, and I'm going to get an alternate value here. We're going to, well, let's double check it, but let's use the law of sines to show that this is actually going to create two solutions here. So this would be side angle C here, and possible angle C here, and this would be side A, or this little one would be side A. So I'm going to highlight, we're talking about that triangle versus that triangle. Okay, so let's see why that's the case. Okay, so let's find angle C, because we have this pair of opposites here. So we're going to do the sine of angle C over side C, which is 20 units, equals the sine of B, which is 29, over side B, which is 15. Multiply both sides times 20, so times 20 times 20. So sine of C equals 20 times sine 29, all over 15. We get sine C is approximately equal to 0.6464 when we plug all of that into the calculator. So if I go to my unit circle here, remembering that the sine is positive in quadrant 1 and 2, and the sine of C is your y coordinate, so we'd be up here at 0.6464, and then you have your circle cruising around like that. So we're looking for this angle here and this angle here. All right, so we go into Desmos and we go, all right, so we're going to find out what angle, reference angle, is created when we plug that in. So we'll do that. Go into Desmos here, and I'll just change this to 0.6464, and we get 40.2 degrees. So let's just call it 40 degrees. That's good. So we'll say C is approximately 40 degrees, and that would be this measure here, but it's also this reference angle over here, 40 degrees. And so here's what we know. this measure is 140 degrees. So is that possible in this situation? Because we're looking at angle B here. This is angle B, and it's 29 degrees. So could this angle over here be, definitely could be 40 degrees, because 29 plus 40 is quite a bit less than 180. And so we could find this top angle up here by subtracting those two values. But could it also be a measure like this? Here's 29, and right here would be 140. Is that possible? So 140 plus 29, that would be 9. That's 169 degrees, which means that this top angle could be 11 degrees. It's totally possible. So in this case, both of these angles are possible. So it's going to create two situations. So we could go with solution 1, where angle C is 40 degrees. And so our picture would look like, well, we'll just solve that triangle. So what we're looking for is angle A, and we just decided that angle C was 40. We already know angle B, so we just need to find what is side A, and then we'll have this triangle solved. Those are the only things that we have left to do. So if I were to draw this picture here just to look at it, here's 29, and over here is going to be 40, and here's angle A, and we need to find that measure there. So we do 180 minus the sum of those, 69, and that would give us what? 111 degrees. So that would be 111 degrees. Okay, and we already know that this side over here is 15, because this was angle B, side B, and so and side C over here was 20. And so now all we have to do is find side A for this situation. So we could use the A over the sine of A, which is 111, equals, and let's use this given information here for our B sine B. So we're going to do 15 over the sine of 29, multiply both sides times sine of 111. So A equals 15 sine 111 over sine of 29, and we plug that into the calculator, and I've already done that, and we get a solution of approximately 29. And so side A is 29. So that would be solution 1 with the missing parts to the given triangle. And then solution 2, in solution 2, C is going to be 140 degrees. So when we draw that picture, it's going to look more like that, where here's your 29 degree angle and this is 111 degrees. And so this top angle we've already found here. We'll just go ahead and write this, that angle A is 11 degrees because we just added, wait, did we? Is it 11? It's not 111, it's 140. What am I doing here? So C is 140 degrees, that picture there, that's C, that's B, that's A. So A is 11 degrees because 140 plus 29 is 169. Subtract that from 180. Okay, and we already know that this is, side B is 15 and side C is 20. So all we have to do left here is find side A. And again, we do the same problem that we just did, except now we are going to use angle A, which is 11 degrees instead of 111 degrees. So we're going to do A over the sine of A, which is 11, equals B, which is 15 over sine of 29, multiply both sides times sine 11, and we'll cancel that out. And we get A is approximately, and we plug all of that in the calculator, and we get approximately 6. And so A is 6. And that is 2 solutions. Okay? And so that's how you use the law of sines to determine if you're going to get one solution, two solutions, or three solutions. I will tell you that I did make videos on YouTube on how to draw these situations to scale so that you can actually use your compass and you can see that they create one solution, zero solutions, or two solutions. In fact, I'll show it to you really quick. I'll just go to my YouTube channel just to show it. Well, no, I'm not, because I told you where it was in Canvas. And so there we go.